Alright friends, so today we are going to be continuing our algebraic manipulation of limits in order to solve ones that sometimes can be indeterminate or prove difficult to us. So I'm just going to split my paper up here. Okay, so this first one, let's see what happens when I plug in -2. If I plug in -2, I get -2 squared minus 4 times -2 minus 12 all over -2 plus 2. So that's going to give me, I like putting parentheses so that I remember I am I'm squaring -2, not just 2. So that would give me 4 plus 8 minus 12 over 0, which gets me 0 over 0. And we know that that is indeterminate, which is not good. We don't like indeterminate. Let me clear up that writing a little bit. Okay. Much better, indeterminate. Okay, I like this much better. Okay, so let's see how we can manipulate this so that we can do something with it, so that when we plug in our -2, when we try to evaluate the limit, we do not get indeterminate. So already I see that the top is factorable. I can factor that quadratic. So I ask myself, what factors of -12 add up to be -4? So I go through my factors of -12. I know 6 and 2 and 3 and 4. And one of them has to be negative in order for it to be a -12. So I could do x minus 6 and x plus 2. So that sounds right. X minus 6 and x plus 2, right? Because -6 plus 2 is -4. -6 times 2 is -12 over x plus 2. And we're in luck because that cancels out. Hopefully you remember from pre-calc that when we have a factor that cancels, that's called a whole, okay? But we're not going to worry about that right now. We're going to keep moving on, but I just want to review that. So now I have the limit as x approaches -2 of x minus 6. So when I plug in -2 now, I get -2 minus 6, and I end up with a number this time instead of an indeterminate result. So I'm happy. Now let's look at this one. Evaluate the limit as x approaches 4 for 4 minus x over 2 minus the square root of x. Okay, so first let's plug in and see what we get. So we get 4 minus 4 over 2 minus the square root of 4. So that gets me 0 over 2 minus 2. Gets me 0 over 0, which is bah-humbug. I get indeterminate again. So I'm like, okay, let's think about how we can manipulate this. So this can kind of be hard to see, but let me give you an example here before I give you the answer. In fact, let me change the color of that so you know that it's a kind of side note. Let's do green. Okay. So hopefully you remember perfect squares. So perfect squares are like when I have x plus 2 times x minus 2, I get x squared minus 4. It's kind of hard to see. Let me see if I can do a different color. Magenta. Okay, that's a nice purple. X plus 2, x minus 2 equals x squared plus minus 4. Okay, and you can look at this forwards and backwards, right? So let's say you're given x squared minus 4. You know that it can break up into these into its perfect square, right? So I know the square root of x squared is x, and the square root of 4 is 2. And I'm just going to have two factors, positive and negative, right? Because that positive and negative gets rid of my b factor. My b, or my b term. This is my b. If looking at this left side here, my b is that middle term. So, and here's why, right? So I'll multiply it out, factor. So I get x squared plus 2x minus 2x minus 4. So these always cancel when you have the same factors but opposite signs. So now let's look at this one. Well, I think this is a perfect square too. It may not look that way because x is by itself, but I know that the square root of x times the square root of x is x. So let's do 2 plus the square root of x and 2 minus the square root of x over 2 minus the square root of x. Hallelujah, we're in luck. I'm going to return to my black. So I get now the limit as x approaches 4 of 2 plus the square root of x. Let's plug in 2 plus the square root of 4 equals 2 plus 2, which equals 4. And Miss Danny is really happy that now she finally has a number. And I encourage you to go check the graph and see if both of these answers, check the graph, match what the graphs say. Okay. Looking at number 3, it says evaluate the limit as x approaches 0 of sine of x over x times 2x minus 1. Okay, so the first thing, we can't assume that it's automatically going to be indeterminate, so let's plug in. So sine at 0 pi, I should say, sine at 0 pi over 0 times 2 times 0 minus 1. I know sine at 0 is 0. It's my y value here. I've got 1, 0. Sine is my y, cosine is my x. And then I got 0 times anything is going to be 0, so all right. We get indeterminate, and we're like, all right, well, what can we do? So we can think, and I'm going to say, okay, let's just try doing some manipulations and see what we get. So I do notice something in here that is familiar, and I know that the limit as x approaches 0 of sine x over x is something I've seen before. Sine of x over x times, we'll have to have this on the bottom in order for it to be the same problem. So I'm like, okay, great. Well, we know from before when we investigated sine of x over x, the limit as x approaches 0 is going to be 1. We know that from investigating its graph. When I plug in 0, now I get 2 times 0 minus 1. Okay, so I get 1 times 1 over 1. Let me see, 2 minus 1, 2, yeah, 2 minus 1. And then I'm going to get 1, which is awesome. We are in business. Ooh, I made a mistake. Hold on. Hopefully you caught it. I was like, I think something's wrong here. I did 2 times 0 minus 1 incorrect in my head. So that's 1 over negative 1, right? Because 0 times 2 is 0 minus 1. And I get negative 1 as my answer. Excellent. Okay, the last thing I want to go over with you all, let's go ahead and apply those limit laws that we looked at. So let's go ahead and look at A. We have the limit as x approaches 2 of g of x plus h of x. I know that from my summative limit law, my sum law, that I can split these up. So I'll help you out by writing what law I use for each one. So what that means is A is really the limit as x approaches 2 of g of x plus the limit as x approaches 2 of h of x. And great news, we know what both of those are, so that's 5 plus 0 because it's given in the problem, so that equals 5. Okay, awesome. Let's do a different color now. Let's do B. So the limit as x approaches 2 for 3 times h of x. Okay, so I know this is my constant multiple law, which tells me I can pull out that 3. So I'd get 3 the limit times the limit as x approaches 2 of h of x. And I'm like, okay, well, I know what the limit as x approaches 2 of h of x is, and that's going to be 5. So now I have 3 times 5, which is 15. Excellent. Okay, now let's do C. I have 2 limits being multiplied together, and I know from the product law that I can do the limit as x approaches 2 of g of x times the limit as x approaches 2 of h of x. Okay, so I'm just going to multiply those outcomes, so 5 times 0 equals 0. That's my answer. And my last one, let's go ahead and do magenta again. I like that one. We're going to be using our quotient law, which says the limit as x approaches 2 can be applied individually to both the top and the bottom, the denominator and the numerator. G of x. And so I'm going to get h of x, it's going to be 5 divided by 0, which I don't quite like, but it is going to give us our an answer. So we know that this is undefined. Whenever I have a number over 0, that's undefined. So not the answer we want. So I'm going to guess that this could be an asymptote. We'll see. We'll see why it's undefined. Could be a whole. So I hope this made sense, and I hope you enjoyed. I look forward to working more with you all on this.